Hello and welcome to Statistically Significant. In today's session, I will be discussing how to solve a transportation problem using Tora software for operations research. So you can see this is a balanced transportation problem given here and we will solve it using Tora. So let's see how to do it. This is the Tora first page when you click on the software. Now go click here. Now see there is an option called transportation model in this pop-up box. You click on it, go to input screen. Now give a title. I am using the title here, transportation. How many sources are there in our problem? 3 sources and 3 destinations. Sorry. Now we press on tab to go into the main page. So you can see an input grid pops up. Now we have to enter the variables of the sources and the destinations. So let us name the destinations as D1, D2 and D3 respectively, and the sources as S1, S2, S3. Now in the cost matrix, we will enter the costs in the problem. They are 873, 873, 389, and in the final row we have 11, 3 and 5. Sorry for the interruption. Yes, final row was 11, 3, 5, right? And now the sub requirements and the availability. So the first we entered the availability there 60, 70 and 80 along this supplies column 60, 70, 80, and the demand or the requirements which is 50, 80 and 80. So 50, 80, 80. You have to be very careful while input. Okay, so now we have entered our data. Now we click on solve menu. Do you wish to save data? You might click yes or no. I am not saving this one. Now solve problem. You can click on final solution, or if you want to see the iterations you can go here. Now there are 3 methods which Tora uses. One is the northwest corner rule, another is the list cost starting method, and the last method is VAM, the Vogel's approximation method. So I will always suggest to solve the problem using VAM, or if in the exam they are asking you to use northwest or least cost, then you might do that, but VAM gives the best solution. So I will click on VAM and that's it. We have got our solution. They say the iteration 1 is optimal, that is in the first iteration the problem is giving us the minimum cost. Okay, now see what we generally do while solving the problem manually. When we apply that cell evaluation method, we initialize the u1 or the ui or the vj as 0 corresponding to that row or column which has the maximum number of allocations. So now see here in our problem, our row 3, sorry, the second row, this row has the maximum number of allocations. You can see there are 2 allocations in this row, 50 and 20. Now have a look how to understand which are our cell allocations. See, these are the VJs, V1, V2, V3. These are the UIs, U1, U2 and U3. These 8, 7 and 3, these are the cost which were there initially in the problem. This minus 11, minus 5, 0, these are the cell evaluations. Now while in my class I taught you guys to check the cell evaluations using the formula del ij equals to Cij minus ui plus vj. But here Tora uses a different formula. What they do, their formula is del ij equals to ui plus vj minus Cij. Okay, so when you guys will do it manually, you will find using my formula it is 11 5 0 is 0. Okay, but actually Tora is using del ij equals to ui plus vj minus Cij. That is why they are getting minus 11 minus 5 as the del values for the non-basic cells. Okay, now 873, these are the costs which were initially in the matrix. 60 is the allocation. Okay, this row is this 60 is the allocation, 50 is the allocation, 20 is the allocation, 80 is the allocation. Okay, so now you can see that all these are satisfied. 60, 60 plus 20, 80 here, 50 plus 20, 70 here, and 80, 80, and this 80, they are all satisfied. Now, what I said, that Tora is not initializing the UI or VJ with the manual method. That is what we do in the manual method. We initialize that UI or VJ equals to 0 corresponding to that row or column which has a maximum number of allocations. So see here here this column also has two allocations and this row also has two allocations. So you can initialize any one of V3 or U2 as 0. So I am initializing here see U2 as 0. Okay. So now what we are getting, the values of U1, U3 they have changed a bit, and you can see that the allocations in each cell they won't change. Basically they want this will not change, and the objective value which is to minimize the transportation cost, it is 750, and this is the minimum cost as software says. It is the first iteration is optimal, so we have reached the optimal solution in the very first iteration. Okay, so this is how we do Tora for solving a transportation problem. Now how to save this? Click on write to printer. Now click OK. Yes, we have got our answer in a printed form. This is the original question. Scroll down and we get our data. We get our answer, sorry, with the cell allocations 60, 20, 50, 80, our cell allocations, and we also get the del ij values for the non-basic cells and the objective function, the minimum cost 750 units. So that's it, how you use Tora to solve a transportation problem. I hope you guys have understood this one. Thank you.